Question number 3 says, the circumference of a circle is growing at the rate of 5 yards per minute. At what rate is the radius growing when the radius is 4 yards? Okay, so take a few seconds. You come up with part 1. I don't want to give it to you. You come up with it. What rate of change was given to you? What rate of change did they give you in this problem? And write it down. If you're doing it right on number 3, like right on this paper, you can put a little 1 with a circle and then write what you're supposed to write right here. Okay? Ramon, what did you come up with? Did they give you a rate of change in this problem? Just look at it. Do you see the word rate near the beginning with a number?
I don't want to say it, I feel like I'm wrong.
Alright, tell me what you think the number is.
I think it's 5.
It is 5. There's a rate of change and it's
I know
5.
that's 5, but I'm
What
saying
is changing at
the
5?
derivative?
The derivative of what?
Of the circumference.
Okay, the derivative of dc dt, that's correct. So,
Yes.
the first step would be dc dt equals 5. Right? Now, the only thing that would make this a little complicated is if it said that it was shrinking at the rate of 5 yards per minute, in which case you would put negative 5.
So do you not put over minutes?
Okay, if you want to put the units here, the units are more important in the answer than they are in the parts. Understand? But I will go ahead and put here, what is it, yards per minute? I'm going to put a YDS over MIN, yards per minute. Yards per minute. Alright, part 2. Alright, identify the unknown rate of change. Write it down. What are they asking you to identify? Yes, that's what they're asking you to identify. It says, at what rate is the radius of the circle growing? So they're asking for dr dt.
Yeah.
What is dr dt? Okay. Step 3. Identify some formula that relates circumference to radius. Does anybody know of a clever formula? 2 pi circumference equals, right? Circumference equals 2 pi r. Right? We're good?
No.
Plug in for any values that are not changing. Is the circumference changing?
Yes.
Is the radius changing? So we got nothing to do. We're not doing step 4. We will, I promise, we will eventually do step 4. Okay. Alright, step 5. Find the derivative of the formula with respect to t. You do it, don't shout it out. You do it. Take about a minute and you do it. See if you can figure out, this one's a little more challenging than area, but I think you can still do it. It's a little more challenging than area, but I think you can still do it. Find the derivative of the circumference formula with respect to t. I wonder if anybody at this point has thought to themselves, oh my gosh, you can actually find the derivative of any formula with respect to t. Isn't that cool? You can find the derivative of any formula in the world with respect to t. What's that? It is, yeah. Yeah, so hang on. Now, what is it going to start with? DC dt equals 2 pi dr dt.
Okay.
You've got to have a dr dt on there because it was still a term that had a radius.
I'm sorry.
Yep.
I'm just not saying this. Okay.
Yeah.
On number 3.
Yes.
Where did you get 35?
We were told in the problem that the circumference, it said when the circumference is 35. Yep, it's okay.
I'm sorry. I thought
Yeah, that's all right.
it was like a random number.
Yep. No. Yeah, that's one of the things. You asked a wonderful question because you asked me a very specific question. Where did that number come from? Right? Unfortunately, too often in math classes, students just say, I don't get it, right? And I can't go anywhere with that. But when somebody says to me, I don't know where the 35 came from, that's a question I can answer. Yeah. Okay.
For number 5, that's what we just did, right?
Yes, we just did step 5.
Step 5.
Yep.
Like, okay, why did you put that?
Why did I put this stuff? Why did I put dc dt? Because in order to do the derivative of this formula with respect to t, I have to ddt this term and I have to ddt this term. The derivative of c is dc dt,
Okay.
right? Just like, remember when we were doing, what's the derivative of y? It was dy dx. Well, now instead of it being an x, it's a t. And instead of it being a y equals, it's a c equals. Does that help a little bit?
But the 2 pi,
We haven't gotten to this yet. Do you understand why we put dc dt?
yeah.
Okay, now. So, now we're going to do the derivative of 2 pi r. What is the derivative of 5x?
Yeah.
It's 5.
Yeah.
Ooh, I
Right?
get it. Okay.
It's
okay,
fine.
okay.
Whenever you have a variable to the first power, isn't the derivative just the coefficient? So this is r to the first power, so it's just 2 pi. It's just a coefficient.
Alright.
Isn't pi just a number? Isn't this number basically just 6.28?
It's not a variable because it can't be used to resemble any number.
Exactly. It only represents 3.141592, etc., etc.
Okay.
How do you know that?
Right? I don't know the future for a while. That's actually pitiful that I only know the first 6.
It's like a whole chart.
Yeah. Do we feel a little bit better? If you understand why the derivative of this is 5, we should then be able to help you understand why the derivative of 2 pi is just 2 pi. But you want to know why I put a drdt on there.
Yeah, like instead of the r, why does it r?
Okay, go.
With the
Oh,
dt?
that's the derivative.
Because that's the derivative. Remember I have to slap on the derivative portion when I don't?
Now I
Yeah.
get it.
Yep.
Thank
Very
you.
good. Yep, you're good. Okay, now.
It's my job.
Alright, so. Now, step 6.
Shut up.
Guys, settle down. Guys, step 6. Plug in all given and implied values. Okay, hang on. How many values do we have here? Or excuse me, how many variables do we have here?
2.
It's actually 2. 1 to plug in for, but there are 2. Look, do you guys notice something interesting here? What do we only have in this formula? We only have derivatives, right? There are no regular variables anymore. You may tell you why? Alright, let me tell you why. It's because both of the variables in the formula were first power variables. This is c to the first power and r to the first power. They're both distance measures, and therefore the rate of change in circumference is directly related to the rate of change in radius with no modifier. It's pretty neat. Anyway, you'll appreciate that someday if you want to go to differential equations class. Okay, so do we know any of these things? Can we plug in for either of those rates of change? We're solving for one, and they gave us the other. Am I right?
Yeah.
Which one did they give us?
DC.
All right, so what are we going to plug in for this?
5.
A 5. We're going to put a 5 equals 2 pi dr dt. Now, can we read the question again? Oh, wait, say it again. They gave us an r, right?
Yeah.
You know what that means?
What does that mean?
What does that mean?
You tell me.
Because there is no r in the derivative, the radius is irrelevant. It doesn't matter. It wouldn't matter what the radius was. The rate of change is actually going to be the same no matter what the radius is.
It's a constant rate of
It's going to
change.
be a constant rate of change. That's correct. Yep. All right, so what is the rate of change? What do I have to do here to solve this? Divide by
2 pi.
2 pi on both sides. Divide by 2 pi, cancel, divide by 2 pi, and I get dr dt
Equals 5 over 2 pi.
is 5 over 2 pi. So, no matter how large this circle is, if the circumference is growing at 5 yards per minute, then guess how fast the radius is growing? At 5 over 2 pi yards per minute. Any guesses on how fast the radius would be growing if the circumference was growing at 7 yards per minute? 7 over 2 pi yards per minute. You got it. So here's a part of the lesson, sort of, is that when you have two linear variables that are related to each other, if one of them has a constant rate of change,
The other one was
if they have to be directly related, like it has to
not
be
distance and an
this,
area, but
right.
distance and a distance.
It has to be, all you have to do is take one of them and multiply by a number and you get the other one. Okay? It's not like the Pythagorean theorem where you have squaring and pluses and stuff.
In this case, it's 1 over 2 pi.
Yeah, yep, it is. The rate is one of the rate differential, or the rate
The thing you multiply to get the
proportion is 1 over 2 pi. Yep. Alright, are we ready to do one that has a step 4?
No,
Number 4 have a step
Really
forward?
don't.
It does. Number 4 has a step 4. Let's do question number 4. Is anybody, I'm curious to know, is there 1 or 2 people in this room that feel a lot more comfortable now than they did 1 hour ago about this?
Oh, yeah. For sure.
Does it seem as though this is way more difficult than the way, well, my past students have made it seem?
The only hard part is like you said, 3.
It really is, coming up with some formula.
Because my
And-
memory sucks.
Yeah, what you're going to see, Chaz, in this question is step 3 is going to be a little harder in this question than it was in the last couple of questions. Okay? All right, let's look at this. Step 4. Or, that's question 4, sorry. Question 4. It says, 1 leg of a right triangle is 20 centimeters long. Does anybody have an urge right now
look it up.
to do something?
Draw a triangle.
Draw a triangle. Thank you. Yeah. I hope everybody's thinking, hey, maybe I should draw a triangle.
Oh, yeah.
Okay?
That'd be awful.
I'm going to draw a triangle. I'm going to draw it over here.
If it's like, it's
So I'm going to draw a right triangle.
that's what it say.
Okay?
Never know about hers.
And what am I going to write on this right triangle?
You like poison people with play.
Not a variable, but a
Constant.
constant. It says 1 leg of a right triangle is 20 centimeters long. Which one do you want to make this one 20 or this one 20? The side or the bottom?
Bottom.
Oh, you don't care about.
Oh, yeah, that doesn't matter. All right, I'll do the bottom. All right, guys, look. Now that I have put a 20 here, you know what that means? That means that this leg is constant. It is not changing. If something is changing, then do not, under any circumstances on your diagram, write a constant value for a distance. So this, what we're going to find in a minute, is that this leg is changing. And because that leg is changing, I am not going to write a value on this side. Understand?
Even though you're going to accept 4.
At some point, I am going to identify that has a value at a snapshot in time.
Oh.
See, what we're doing is, in these situations, what we do is, the triangle is growing or shrinking or doing something, and at some point or another, after we take the derivative, after we have done step 5, once we've done step 5, that's when the diagram gets to freeze up, and then we can start using constant values. Okay? All right, but until we take the derivative, this is fluid. This is moving. Okay, so look. It says 1 leg of a right triangle is 20 centimeters long. The other leg is growing at the rate of 2 centimeters per second. At what rate is the hypotenuse growing when the hypotenuse, is 25 centimeters long? Okay. That was a lot. But let's look at step 1. Let's use our steps to break it down for us, okay?
Yeah.
Identify all given rates of change. Were we given any rates of change?
Give it 2.
What were we given?
A 2 centimeters.
A 2, right? It says one of the leg, it says the other leg is growing at 2 centimeters per second.
2 cm over.
Say again?
2 cm over. Like 2 centimeters a second.
2 centimeters per second. So, 2 centimeters per second. But don't we need to call this something?
Yeah.
I'll tell you what. Let's not call it anything for now. Let's think about what we should call this derivative. Now, we know that the derivative is going to have what in it?
Because we don't know what it is.
It's going to have a d. What else is it going to have? It's going to have a dt. So we know that it's going to be a rate of change that's d something dt. Am I right? Are you?
Yep.
I'm looking for the people who don't understand why I did that. Is there anybody who does not understand why I put a ddt equals? And here's the thing is, we're trying to figure out what we should put here. What is that letter representing? A leg of what? A leg of what kind of triangle? A leg of a right triangle. A leg of a right triangle. Has anybody ever in their life ever used a letter to represent a leg of a right, the length of a leg of a right triangle? A.
A or B.
A or B, right?
Not just what you did.
Okay? Why don't we just use one of those?
Let's do it then.
You want to use A? B. All right, we'll call this one B. And if this one's B,
BBDT.
the hypotenuse is
C.
C, and this 20 here is
A.
A. So we're just, now we don't know if this is going to help us at all, but we are accustomed, haven't we, for years been calling the sides of a right triangle A, B, and C, right? Okay, where the C is the hypotenuse. So now what are we going to say about that this is dB dt, right? So the rate of change in one of the legs of a right triangle is 2 centimeters per second. Why did we make it positive instead of negative? It doesn't say shrinking, it says growing. Okay. All right, now it says, step 2, identify the unknown rate of change. Say again? Malakia says dC over dt.
I agree.
You agree? Okay, why? What is that? That's the
Hypotenuse.
rate of change in the hypotenuse, right? Which is what it says. It says at what rate is the hypotenuse changing or growing. So it's dC dt is what we're trying to figure out. All right, now it's going to get fun.
Oh,
It's actually not that bad, but can anyone in this room think of some formula out there in the math world that relates B and C?
Pythagorean theorem.
A
Pythagorean
B
theorem.
squared equals C squared.
A squared plus B squared equals C squared. See, now, it's not as hard as it used to be, am I right?
I don't know how to do taxes, but I will remember that equation.
You won't remember what?
I said I don't know how to do my taxes, but I'll remember.
But you remember
that
A squared
day I
plus.
die.
You know what's amazing? I have noticed that students don't know how to write the equation of a line, but they will always know that. I don't know what they're doing in 5th grade. To y'all here in Rockdale County,
It's
but
like
everyone knows
ABC
Pythagorean
with
theorem.
Literally drilling it into our brain.
Yeah. All right, but we know that A relationship. Is this the only relationship between C and B?
No.
No, it's not. How about the law of sines or the law of cosines? Wouldn't those also relate A and C? Yeah?
That's right.
I hate those.
You can at a later date if you want to. At a later date. You know what that would require us to do, Brandon? We would actually have to identify the angle measures. Yeah, which would actually be more difficult. So we want to go with the simplest formula that we can come up with, right? All right, now, Ramon, are you ready?
God.
Are we ready? Okay. Step 4.
All right, Ramon.
Plug in values for any unchanging variables. Is one of these not changing?
A.
A is not changing. What is its value?
20.
20. So we're now going to change it to 20 squared plus B squared equals C squared.
Okay.
We have now modified the formula, and now when we do step 5, we're going to do it to the modified formula, not the original formula. What's that? All right. Step 5. Find the derivative of this new formula with respect to t. What is the derivative of 20 squared? Think about it. What's that?
40.
It's 0.
Yeah, because there's no variable.
Isn't this a constant? There's no variable. So the derivative is 0. Right? Now, guys, as an aside, okay? As an aside here, okay?
Let it be.
What would the derivative of a squared be? 2a and something else. Remember, we're doing dA dt. Okay? Please pay attention to this, folks. Look,
Pay attention.
the derivative of a squared would be 2a dA dt, right?
Right.
All right. Well, what is dA dt? What is the rate of change in A? So what's its rate of change?
0.
0. So even if we did do 2a dA dt, since dA dt is 0, what is 0 times 2a?
0.
It would become 0 anyway. Do you see how even if you forget to plug in for a constant,
Sometimes
you'll
it
still
works.
come back to the fact that it would become 0?
Yeah.
Okay, alright, so but we're gonna go ahead and do the derivative modified formula. The derivative of a constant is 0, so we're not even gonna write anything.
So it's just gonna be b squared
B
equals
squared
c
equals-
squared?
Yep, B, so we're dealing now, well, it's not, right, that's what we're now dealing with, that's the derivative, yeah. So what would the derivative of b squared be?
To be.
2b or not
2b.
2b.
Okay.
Oh.
When would it ever not
I only get to do that 3 times a year, folks. I only get to do that
be?
3
Like,
times
your
a year.
finger off. Yeah.
Once in each period.
Just don't hold score.
Sorry.
That's not the right play.
Yeah, right.
It's funny.
Alright, so the derivative of b squared is 2b and what else?
Relates to itself.
db dt. You have to put a db dt on there, right? Equals. Now, what is the derivative of c squared?
2c.
2c with
My eyes.
dcs. I was waiting for it. dc dt. Alright,
I didn't get that one.
It's okay.
2c.
Just don't.
2c.
I didn't hear what he said. 2C was what?
Your
2c
eyes.
with my eyes.
Okay,
Ramon, it's okay.
Dude, visuals. You know,
it
look-
wasn't a theater related joke, no. Okay, so now, step 6. Now, just so you know, and you don't have to do this step, but looking at this formula, does anybody see a simplification thing that you could do here? Well, how could you make this a little simpler, this formula? Yeah, you could divide by 2 on both sides. Look at this, you could cancel the 2's. You don't have, we're not gonna, I'm not gonna just be for the people who don't want to, okay?
Do it anyway.
But do you see how you can actually cancel the 2's and just make it b db dt equals c dc dt? Because we can divide both sides by 2 algebraically and cancel the 2's, right? Alright, so now, step 6. Plug in all given and implied values. What are we given here? What are we told? We're given db dt, right? Which is 2. So I've got 2 and then something, b, whatever b is, and then db dt is also 2, right? Please, guys, I need you to ask questions if you don't know what I'm doing here.
Chaz, that's what-
Alright, go.
Just ask
Go
a question.
down.
Now, what else? Then we have equals. Oh, well, yeah, equals 2c, but I'm leaving the 2's on, but if you want to just do the c, that's fine. What is c? Are we given c? Look in the problem.
Yes, it's 25.
Yes, it says, at what rate is the hypotenuse changing when it is 25 centimeters long, right? So we do know what c is. We do know the hypotenuse, it's 25. And then what are we going to do with the dc dt?
This is right there.
Yeah, we're going to leave it alone because that's what we're solving for. Now, we have a problem. The question did not give us the length of b.
No.
What's that? In a way it did. It implied the length of b, right? And what did you say it is? It is 15. How do you know that it's 15?
Because this is a triangle. It's a 3, 4, 5.
This is a 3, 4, 5 triangle. Yep. If the, I don't know if y'all are familiar with 3, 4, 5 triangle, 3, 4, 5 triangle. That if one leg is 3 and one leg is 4, the other leg is 5, right? Well, you can also multiply. If you multiply the 3, 4, 5 by any multiplier, it stays a 3, 4, 5 triangle. In this case, the hypotenuse is 25, which is 5 times 5. One of the legs is 20, which is 5 times 4.
I would never have
So the
thought
third
that.
side must be 5 times 3, which is 15. And if you did the Pythagorean theorem on this, you would get the length of b, which is 15. Okay? So if you did
Oh, yeah.
20 squared plus b squared equals 25 squared, 20 squared is 400 plus b squared equals, what's 25 squared? 625? Subtract 400 from both sides, and you would get b squared equals 225. Then do the square root of both sides, and b is equal to 15. Okay. So, b is 15. We have now plugged in for an implied value. We've plugged in all of our given and implied values. Step 7, solve. 2 times 2 is 4. 4 times 15 is 60. Equals 2 times 25 is 50. dc dt, last step.
Divide by 50.
Divide by 50 on both sides and reduce, and what do we get?
1, 4,
We get 6 over 5, 6/5. So the rate of change in the hypotenuse at that particular moment in time is 6 over 5 centimeters per second. You did it. We did it.
Huh.
We did it.
We got Dora. My kids used to watch Dora. I actually like that song. It would stick in your brain. I thought it was like, yay, big celebration, you know? We celebrate good times. Come on. Timeless song, right? Yeah. Oh no, it's celebrate good times. Yeah, and then they say it's a celebration. We have time for one more.
No, we don't.
Let's do one more. Yeah, let's do one more. You
I'd
don't.
rather not.
Alright, let's do one more. Let's do, hang on. Let me pick a good one on here. We might do number 5, but we might,
Number 6.
yeah, let's do 6. Yeah, let's do number 6. Yes, we can.
Wait, this is shrieking.
Anybody want another one of these?
Yes.
Here, I'll give everybody another. Oh, you don't. You're not
Oh,
gonna
because the rate. Are you?
Yeah. And another one that and another one that direction. Say again? Yeah. Yeah, and because it actually has all 3 sides that are changing.
Do you have a hope?
Yeah, it's a good one. And it's behind you. Yeah, it's over there, but don't budge the camera or don't, nudge the camera.
Are
or
you like
whatever.
videotaping right now?
Yeah, behind you.
Oh man, so I'm gonna be in it.
Okay. Alright. Well, I can edit you out.
Do the Facebook thing.
Please don't.
How old are you? Is it recording?
What?
Oh, I thought it was recording. It just says low battery.
Oh, that's fine. I hope.
Does
Okay.
that stop the video?
What? It doesn't stop the
No,
video.
it won't stop the video, but it will if the battery drains shut down.
Yeah,
Yeah.
I thought it like stopped the video.
Alright. Question number, we're doing question number 6. It says, and you'll see in a minute why I want to do this one. It says one leg of a right triangle.
Which one? I'm sorry.
Question 6. One leg of a right triangle is growing at the rate of 80 feet per second, and the other leg is shrinking at the rate of 50 feet per second. At one instant, the growing leg is 350 feet long, and the shrinking leg is 200 feet long. At that instant, at what rate is the length of the hypotenuse changing? All right, step 1. Identify all given rates of change. Go, try it. See if you can identify the given rates of change. Here's another reason I like this question, is that there is more than one given rate of change. This finally came up. Who's not here? We're missing Jeremy.
You're missing Jeremy. You're missing
Tiffany.
Danielle.
And Danielle.
And you're missing Tiffany.
Alright.
Tiff, Dan, Jared.
Missing Tiffany. Missing Jeremy. Who else?
Danielle.
Danielle, that's right. Alright. Is that all? Yeah, I guess that's all. Okay. So, what do you guys think?
Hold on.
Go ahead. Sorry. Did somebody come up with one? Go ahead. Thank you. Thank you. Can somebody just give me one of the rates of change?
I have DADT equals 80 feet per
Alright.
second.
Say D what?
DADT.
DADT is what?
I put 80 feet per second.
80 feet per second. Alright, good. There's another rate of change given, isn't there?
Yes.
What is it? dB/dt, another side of the triangle. So we have side A and then side B. What's dB/dt?
-50.
Negative 50. Why is it negative 50 instead of 50?
Oh yeah, it's shrinking.
It's shrinking,
I forget.
right?
Right?
That's right.
Remember, derivatives that are negative indicate decreasing values, right?
Yeah.
Now, it says identify the unknown rate of change. What are we looking for here?
DCDT.
We want to know what dC/dt is. Step 3, identify a formula. Is there some formula in the math world that relates C, A, and B?
Right here.
A squared plus B squared equals C squared. Yep. Now, are any of these sides not changing?
No, they're all.
They're all changing, right? So we're going to skip step 4, right? All right, step 5. Find the derivative of the formula with respect to t. So 2a Yep. Wait, I got a 2a with a what?
DADT,
With a DADT, okay?
2D,
Plus 2b dBdt equals 2c dCdt. How are we doing?
12.
Does that make sense, this derivative here? Right? And now that we're good at implicit differentiation, it's not that big of a deal, right?
No, not
Now,
at all.
In this one, in this particular problem, I'm going to go ahead and divide by 2. It's going to be a lot easier to deal with not having these 2's in here. Because there's a 2 in every one of these, if I divide by 2 here, divide by 2 here, and divide by 2 here, I've obeyed all the rules of algebra, and I make the formula simpler. And now the formula is A dA/dt plus B dB/dt equals C dC/dt. Okay? How many variables do we have?
3.
6.
6. We have 3 sides and 3 rates of change. That means how many do we have to plug in for to solve? We gotta plug in 5 to solve for the 6th, right? All right. Up here we know what dA/dt is. That's 80, right? We know what dB/dt is. That's negative 50, right? And were we given any of the lengths of the sides?
Yes.
What did they tell us?
350 feet.
Which one is that? Is that the growing one or the shrinking one?
A is the growing one.
The growing one. So A is 350. The shrinking one, and I gotta put this plus in here. What's the shrinking one?
200.
200, because there's this one instant where one leg is 350 and the other leg is 200. And then we need the hypotenuse length, don't we?
Yeah.
And then we're gonna solve for dCdt. How do I find the hypotenuse length?
Put A
A
squared
squared.
through.
A squared plus B squared equals C squared. So I gotta do this could be fun. I'm gonna do it in red. Okay? Alright, so I've got 350 squared plus 200 squared equals C squared. Well, what's 350 squared? You may need your calculator.
Probably.
122,500. And what is 200 squared?
440,000.
40,000. And so equals C squared. So this is 162,500 equals C squared.
Square root
Square
of
root.
that, I don't know.
Square root,
Yeah.
right?
I
Yeah.
don't
Now
know.
the good. You know why? You want to know the good news, Adrian?
Yes.
Just find the square
Is
root
we
of
can just plug that number in here. I'd rather not use a decimal right now. I think I'd like to just use it as the square root
Okay.
because it's not a perfect square. So what I'm going to do is in for C, I'm simply going to plug in the value. Square root of 162,500. And now, you can go. So now, what is 350 times 80? Can somebody figure that out? 350 times 80?
28,000.
28,000?
Yeah.
Alright, 28,000. And then what's 200 times negative 50 here?
Negative 10,000.
Negative 10,000, so minus 10,000 equals the square root of 162,500 dCdt. We are eventually going to put all this in the calculator, by the way. And what's 28,000 minus 10,000? That's 18,000. So basically what we have here is 18,000 is equal to the square root of 162,500 times dCdt. One step left.
Divide by the.
Divide by that square root, right? Divide by the square root of 162,500 on both sides. What's wrong?
The clicking.
Ramona's funny.
I'm not crazy.
All right,
Ah.
cancel. And now, is anyone willing to, in a calculator, can you plug in what is 18,000 divided by the square root of 162,500?
44.6525.
All right. So, the rate of change in the hypotenuse at that very instant. Is the hypotenuse growing or is it shrinking?
Growing.
How do we know it's growing? Because the derivative, the rate of change is positive.
What the?
And this is in feet per second. I think it's feet per second, right?
Yep.
It's in feet per second. Dude!
44.6525.
Tell me that what we just did is not kind of awesome.